Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. Yet again, we are broadcasting live from the downtown Manhattan Adafruit factory, where we do all of our manufacturing and coding and shipping and tester design, all the good stuff that you love. It ships here from Adafruit in New York City. New York strong, New York coming back. It's going to be a great summer. Me, Lady Ada, with me, Mr. Lady Ada on camera control, busy just keeping everything running behind the scenes. While I do the engineering. We've got an exciting show for you tonight. Got about an hour plus of all sorts of cool stuff. Lots of videos, lots of tutorials, lots of new products. It's jam-packed. We even have the coupon code. That's right. The coupon code is back. So why don't we get started, because people want to know that coupon code.
Yeah. On tonight's show, the code is keycaps, 10% off in the Adafruit store all the way up to probably midnight. It's when I remember to turn it off, but you should probably put lots of stuff in your cart as we do the show, and then check out at the very end because we have a lot of new products. Keycaps is the code, 10% off on Adafruit store on checkout. We're going to talk about some of our live shows, things that are going on. We had our show and tell. We're going to have some time travel, look around the world, makers, hackers, artists, engineers, news, and more. Help wanted from the jobs board, jobs.adafruit.com. Some manufacturing factory footage here in New York City from Adafruit. Some 3D printing. We got Ion MPI from DigiKey and Adafruit. We got new products. We got top secret. We got questions that you have, and we're going to answer them. We do that on Discord, adafruit.it/Discord. Join all 29,000 of us.
It's free.
All that and more on tonight's show. It's Ask an Engineer.
Yeah. I'm so excited. I'm like getting back to the groove of doing it live from Adafruit again.
That's right.
It's cool.
Let's talk about the free stuff. So, you know, you can put the code in, keycaps, but
10%.
If you look closely, when you add stuff to your cart, you might see that you get free stuff.
Freebies, $99 or more, you get a free Permaproto half-size breadboard PCB, great for, we see them in projects all the time. People can make nice durable prototypes. $149 or more, you'll get a STEMMA QT board. We've got various sensors, accelerometers, temperature sensors. We have even QT and MCP221s. Whatever we've got in stock, we got a range of 20 different things. So if you make an account, we'll send you a different one each time. If you don't make an account, you'll just get a random one. But if we make an account, we can keep track of which ones you sent.
Okay.
As this is a half-size breadboard, you want to show that off?
Yeah, we got this.
We got that. We got this.
Yeah.
We got that.
Yeah.
Free shipping, $199 or more,
Yeah.
and at $299 or more, you get a free Circuit Playground Express with a SAMD 21, our all-in-one development board. It's our favorite board. People love it. Just today, some people were saying, great for workshops, great for beginners.
Yeah.
Write code in Arduino, make code, CircuitPython. I think MicroPython's working on support too.
TinyGo, Rust.
TinyGo, Rust. You name it, we got it.
Okay, we have a bunch of live shows. We just wrapped up show and tell. I'll talk about some of the stuff on the show and tell later, but there's so many people on show and tell each week, so don't forget to go to any of our social media places, any of our video places. A lot of people use YouTube, and check out the latest show and tell. Highlight this week, Kyle, the CEO of iFixit, was on, and I'll talk about that a little bit later while I was on, and more. Other live shows that we have is we do Desk of Lady Ada, and we do that every single Sunday. Lady Ada, what was on Desk of Lady Ada Part 1?
Okay. So, first off, we got this TI-84 Python Edition calculator, which we should do a teardown using the iFixit kit that Kyle showed off. And I also showed off, we've been working on the MacroPad. I'm actually about to send off like PCBs today. The MacroPad's been taking a while, but it's going to be really good. I want to make it like really a wonderful product with like really good art and like all the design and the speaker stuff.
Yeah.
And then we're going to do more MacroPads. The first one's always the toughest, so I showed that off.
Also, the press agency that works with TI got back to me. They have the questions I sent over about this calculator, because we wanted to know why did they use a fork of CircuitPython and more things like that. So thank you, everyone at TI and the group that's doing that there. And then we have the Great Search, which has the theme song.
Where in the world is that part I need? The Great Search with DigiKey.
And this is when Lady Ada uses her powers of good engineering to go to the DigiKey site and find things. So what did you look for this week?
So in the keyboard theme, I'm working on the KB2040, which is a board that is going to have CircuitPython support with the RP2040 for making mechanical keyboards. And it's the same shape and overall functionality as a Pro Micro. And the Pro Micro, the keyboard board that people use, has a little fuse on it. And I want to make sure that we have a similar spec fuse. So I show how to specify PTC fuses, a couple different sizes, some things to look for, the difference between hold and trip, current, as well as like other specifications that may be important, so that I can add a fuse to this board to make sure that keyboards are protected in case like there's a short or something. It won't like make your motherboard sad.
Okay, and then every single Tuesday there is JP's Product Pick of the Week. It's a show that's broadcast live from the product page itself, and during that time there's a discount. You don't even need to use a code during that time, and this is a recap from this week.
It is the Slider Trinky. It can act as a MIDI device, a USB HID keyboard, mouse. This is a little laptop of mine, and I have some DJ software running on here. This software I'm using is able to be configured to look at a MIDI input for moving that crossfader around. And what I can do is use the slider here to crossfade between It is the Slider Trinky. It is a fader on a USB stick, and it has a couple of underlit NeoPixels as well as a capacitive touch button on it. And it runs CircuitPython and Arduino on the Cortex M0 that is built right on there.
All right, and then there's also JP's workshop. That's tomorrow. But one thing to keep in mind, next week JP's off because he's on vacation.
Well-deserved break. People are starting to go on vacation,
Yeah.
which is wonderful.
Yeah.
So he'll be back in a week.
And during JP's shows, which will be one tomorrow, you'll be able to check out the CircuitPython parsec. Here is the one from the most recent show.
For the CircuitPython parsec today, I want to talk about debouncer. A debouncer is used to prevent mechanical buttons and switches from rapidly registering multiple clicks when you touch them. This blue switch on the left is using no debouncer. The microcontroller is going to read whenever I click, and it's going to advance this NeoPixel, this blue NeoPixel, by 1 each time I click. And you'll notice I can't click it just once. This yellow button on the right, this one's using the debouncer, so that means I can very nicely and neatly and gently click one at a time through these NeoPixels. It's really hard to get this blue one where I want. If you look at the code here, you can see I'm importing the digital I/O library as well as the debouncer library. The blue button is just a traditional digital in-out, and I'm using with a pull-up resistor. The yellow one, I set that input pin, but then I use the debouncer to set up this button. Yellow is debouncer on that pin that we've set up the same way. The debouncer update, so button yellow.update right here, checks the debouncer, so it's polling to see if something happens. And then this is the condition for me pressing it. The value falls, so it goes from high voltage to low voltage. That means I've pressed it. It's a sort of discrete event, so it means we don't get that bouncing, we don't register multiple clicks, and it doesn't matter how long I hold it. When the button goes back up from low to high, it is a separate event, so that means I can also record that. And so that is how you can use the Adafruit debouncer. And that is your CircuitPython parsec.
All right, and if you want to watch Deep Dive with Scott this Friday, you can't. Scott's on vacation too, so for the next 2 weeks, there's no deep dive. Just a reminder, Scott will be back, and
But it's good. He's taking,
It is.
again, another well-deserved break. People taking vacations. He's going to come back, and he's going to go hard on this Bluetooth provisioning and coding implementation that's been working on, which people have been watching him work on during the deep dives. When he comes back, he's going to fix a bunch of bugs. He's going to make it even better than ever. It'll be cool. You can be able to do over-the-air programming of CircuitPython and deploying files, which is going to be really neat because it'll work from mobile as well as a desktop and from other CircuitPython boards. Amazing. Mind blown. Blinka is so cool.
all right. Time travel, look around the world of makers, hackers, artists, engineers. I got a bunch of stuff this week, so I'm just
Okay.
going to roll into it and more. So time travel, so I contacted all of the folks in the EU, the UK, and Switzerland and let them know that we're currently not doing subscriptions to those locations because everything is quadruple, triple costs. There's new import, there's taxes, there's fees. We wouldn't be able to do the AdaBox at the price that we said. So we said, hey, we're pausing this. Never going to charge you again. That was your last AdaBox. And we send them a discount code. Most people are nice, 2 weren't. That's the way it goes. But we do have some good news with AdaBoxes. That means we can open up more in the US.
So we did.
So we did.
I think there's even a couple slots open right now.
We are. And there'll be even more.
Yes.
So that's the good news. But, you know, unfortunately, we're not turning into the Federation of Planets. We're turning into like little kingdoms around the world. And it's getting harder and harder to send anything internationally. And the price, it's mostly a cost. And AdaBox is supposed to be low cost and not super expensive. So you could still get them if you're in Europe or the UK or Switzerland as standalone boxes, probably from places like Pomeroni. But that is the end of those for now. All right, every single day, Monday through Friday, unless it's a holiday or something like that, we have one of the most popular video series already on our social media channels, Lab Notes with Colin. So here they are, back to back. They're a minute each. Take it away, Colin.
You'll see most mechanical keyboards listed as having switches which are Cherry MX compatible. This means they work with keycaps that have a cross-shaped socket, like this one. This standardized socket makes it easy to swap out your caps for another color, or shape, also known as keycap profile. There are several common keycap profiles with varied characteristics, ranging from DSA or XDA with a low uniform height, up to SA profile with tall caps of varying heights, or something in between, like the more common Cherry profile. The differing heights per row make the caps easier to reach from a central hand position. It's more ergonomic, but it means you can't really rearrange your caps if you want to, say, try a Dvorak layout. A lot of boards, like the Feather microcontroller here, feature 0.1-inch spaced solderable holes that make breadboarding easy. Solder header pins on, plug it in, and you've got a strong connection. If you want to attach accessories to your board, like this Feather wing, solder socket headers to the Feather instead. Solder pins to the Feather wing, and attach. What's that? You want to plug a microcontroller into a breadboard and attach an accessory? Well, you're in luck, because stacking headers are a thing. They're a combo of plug and socket headers, essentially socket headers with very long pins. Align them for soldering by plugging a matching daughter board into the sockets. Solder the base of each long pin to a pad. And now you're double stacking electronics. Nice. If you have development or breakout boards, you've probably already seen PCB solder jumpers. There's sections of copper on the PCB that can be used for post-manufacturing configuration, for example, to change pin settings or I2C addresses. This board has both default closed and default open jumpers. Closed have a tiny little copper trace connecting the two larger pads, and the ones below here have no connection. Adafruit boards use this triangular shape to indicate a default open jumper. To open a closed jumper, just use a blade or sharp screwdriver to remove the thin connecting trace. To close an open jumper, use a soldering iron to heat up one pad, melt on solder, and use your iron's tip to bridge solder over onto the other pad. To reopen it, just remove the solder with some solder wick. I2C is a method for connecting devices and sensors to a microcontroller board or computer. It only has 4 pins: power, ground, clock, and data. There are I2C motion sensors, thermometers, air quality sensors, OLEDs, GPS modules, a wide range of devices. But I2C's special feature is its ability to connect multiple devices simultaneously. Stemma QT boards like these can easily chain together multiple devices with a cable. Just keep in mind that each device in an I2C chain needs to have its own unique address. And devices with addresses that can't be changed can only be used once in a chain. If a board does have a fixed address, you'll usually see it printed on the back of the PCB. And if its address can be changed, you'll usually see a jumper or pin that'll let you do it. When starting out with electronics, it's common to forget about connecting grounds. When you have separate electronic circuits sharing signals, like this data line here, even if they're using separate power supplies, the ground wires should almost always be connected. So here I've got an Arduino compatible, powered from a 9-volt wall plug. I want to use it to control a long strip of NeoPixels, which will use its own 5-volt power supply. So, even while using different supplies, the NeoPixel ground needs to connect to the Metro ground. Otherwise, the data won't transmit correctly. It's as if the signal is a little shy, and it'll only venture out into another circuit if it can see a clear way to get back home.
All right, that's all of the Collins Labs for this week. And next up, Phil B made a very charming, nice video about Creative Computing Magazine. If you look really close, you could see a DigiKey ad from decades ago.
Creative Computing Magazine was published from 1974 through 85. It's always fun skimming through these old issues, especially the ads. Tons of printers and maybe 3 hard drives. 5 megabytes was about $3,000. The old Microsoft Heavy Metal Band logo. Shut the front door! Double-sided floppy disks! Oh, free Heathkit catalog. I'm sending that in. What distinguished it from later publications, there's a hint of it here on the cover. All these different systems. Also, all different programming languages. Pascal, Assembly, Basic, which they did not dismiss as baby talk programming for potheads. Home computers were new, and there was just this broad enthusiasm for the whole thing. I think back on creative computing whenever people get into heated debates about Arduino versus Python, or when they talk about the latest Arduino or Raspberry Pi killer. Why the focus on killing? Today, we're in exciting times again. Maybe we could learn something from these old magazines.
Okay, next up, we have Juneteenth coming up here at Adafruit. It's a holiday we do here at Adafruit. So it's Saturday, the 19th, but we do holidays so folks can take time off. A lot of people don't work on Saturdays, so they work on Fridays.
Same with July 4th this year.
July 4th is a company holiday, and we're doing the 2nd and the 5th. So we may have a notice on our site that shipping may be delayed for those days. So FYI. Next up, this was in the Maker News. Altium was like, hey, you got to give me more billions. So Autodesk tried to get Altium, purchasing them.
Which they already own EagleCAD.
Yeah, and Tinkercad.
And Tinkercad.
Yeah.
So it's interesting that they were like, they're trying to sweep together. Altium is
Yeah.
a very popular CAD software.
I got a blog post
Yeah.
when I was talking about Siemens acquiring Hackaday, Tindy, Supplyframe, and I started to put all the acquisitions. There's only like 3 or 4 companies, us included, that aren't acquired. Anyways, speaking of,
Still independent.
I sent over my questions to Siemens. So Siemens bought Supplyframe, which owns Hackaday Tindy. A million years ago, I started Hackaday. That's the logo I made, and I haven't had anything to do with it for a while. And Supplyframe's been doing a good job with a lot of the things that I wanted to do with Hackaday.
Yes.
So now I had
Magazines
I had a
and
question at the
contests,
end. I was like, well, maybe take good care of it because
Yes.
I
Not a question.
it wasn't a question.
Request.
So I sent it over to them. I don't know if they're going to be able to do the questions. We'll see. They're good questions. There was no, dunking or gotchas. They
Nope.
were just questions that I know the community had. We'll see what happens. I'll keep everybody updated every single week. I'll let you know how it goes. Help wanted, jobs.adafruit.com is the board that we have. Not a PCB board, but a jobs board. You post your skills, or if you're a company, you can find someone cool. So this is from Circuit Dojo, Branford, Connecticut. They're looking for a sheet metal enclosure CAD work contract job. So check it out.
Connecticut is like land of sheet metal enclosure works. This is a good idea for that location to look for someone to help with CAD.
Yeah.
You know, machinery like Connecticut, like they invented milling machines.
They have it all?
Kind of.
Python on Hardware News. We got a lot of stuff going on this week. There's so much stuff. We were just in our meeting. We do a remote team meeting with all of us before our shows, and there's so much Python news, and that's what's been happening with the newsletter. So this week, going to do a couple highlights, and then I'm going to pick one thing out that I
Yeah.
think is kind of important. So we have the CircuitPython 7 Alpha 3 releases, 6.3.0 stable releases.
Yes.
If you check it out, we got the new poster with the MicroPython snake and the CircuitPython Blinka,
Hanging out.
along with the keyboard there. Talked about the Raspberry Pi chips. The RP2040s are available for $1 in single units. We also stock them. We have packs of 10 as well. PyRTOS for CircuitPython runs on the Metro M4. I'm going to be talking about the switch from our repositories to main shortly. We have a great interview with Armstrong, who is on our show and tell, and we have posted the interview, text interview, on our website. This is a Q&A, programming with microcontrollers, CircuitPython author
He's got a
Armstrong.
really cool
Sabiro.
story. Check it out.
Yep. Check out some of the videos, some of the news around the web. The PyCon videos have all been posted. So if you didn't make it to PyCon, virtually, you can watch it now. Lots and lots and lots and lots and lots of keyboard-related things. The multipass, which is on our show and tell. Minecraft controllers, you name it, it's happening with Python on hardware. Python, in particular, is becoming more and more popular. It'll probably end up being #1 programming language in the world as far as number of people using it. So we cover that news and a bunch of other things. But as you can tell, it's a never-ending story about all the things that are going on with Python. And one of the best things about Python is the inclusive community. And that's what I'm going to talk about this week. So happy Pride Month, everybody.
Yeah.
If you look really close in the back here, we have our flag. See, it's
Yeah, we
it's
put
right
this
there.
up every year.
Yeah.
Well, last year we were
Yeah, well,
broadcasting not from here, but it's
yeah. Last year, around this time, I would come in after our show, and then I would, we had our, like, chemical suits that we were using the spray downator for this thing. June, I think we were still doing that at night.
Yeah.
Because surface vectors for a virus attack was unknown, so we're just like, well, let's make sure we sanitize everything all the time, always, forever. And we didn't get sick, so hopefully it worked out. So anyways, this month is Pride Month, and I think it's a good time to reflect on some stuff. But most of all, if you're a technologist, there are some things you can do to be inclusive, to get rid of some old language that doesn't make sense anymore, and also to understand where other people are coming from. So the thing that we worked on, and we've been doing this for a bit across different things, is there's an old term, and it's derived from BitKeeper, master and slave for repos, repositories of software. And you can change it to main. And GitHub and Microsoft made a big announcement. We're going to make it easy for you. We're going to do this.
Yes, it's actually like a one-click thing in GitHub as well.
That's right. And that was something that's really important to us, important to our team. And if you're a technologist, you can do this. And if you're an open source community like we are, it reflects poorly if you ignore something that people really want. So the neat thing that's happening is it's working. So we're on main. There's a lot of other organizations on main. The day that we did our post about this with all the resources on how to do it, on some of the other efforts, Make posted up. Mosi and Miso, 140 years of wrong. So Make is changing the language for their magazine with these things as well, including what the pin stand for. There's lots of efforts, and Oshawa and more. And then after we did Master of the Main, that night, SparkFun changed theirs, 1038. They went from master to main. Then, within a week, Arduino went from master to main. So if you look at our post, there is a lot of organizations, and I just started finding some logos really quick. So about 80% of the open source hardware now, when you add Adafruit and SparkFun, have made that switch.
And Arduino
The
too.
Software Conservatory, they do Git, and they have that as a default.
Yep.
Python Foundation is the ones that kind of got us all to, or one of the ones that said, hey, this is important, we can do this. Make is changing their language. The Linux kernel also changed it. Red Hat, going across all of the Linuxy stuff that they touch and more. So this is happening, and I really think that if you're someone who maintains repositories, it's something, yes, it's a little bit of work, but you can do it. And I know that there's this idea that, well, does it really matter? Does it solve things? No, it's a drop, but get enough drops, you got a notion. That's the type of change that we can do as
And
technologists.
also remind people that when they are naming things going forward, like, let's think about the language we use, right?
Yeah.
Because it's like, just because we've had a long history of using certain words and they come up over and over again, like the GitHub naming came from BitKeeper. And the BitKeeper guy said, oh, I got it from something else. Like, it becomes a viral decision. And so if you break the chain now, we can keep people from using these same words over and over again, come up with better, more descriptive names that make more sense.
And I'll just say this because, like, Lady and I get really crummy emails from people who don't like rainbows, don't like equality. We're easy to get a hold of. And I think one of the things is they themselves can't imagine why it's a big deal, but they don't work in a place with diversity, or they don't know other people that have different backgrounds, and so they can't imagine it. But it's a simple thing that you could do if you're a technologist. And
Part of a bigger amount of work that you
Yeah.
do. This isn't the only thing you're
yeah,
going to
it's
do.
more than a hashtag. It's more than just like I care. It's something that we can all do.
But you start with this.
Yeah, we
you
all
can build on that.
we all have little things that we can do, and if you do something every day, eventually there could be good change. So that is the Python on Hardware news this week.
Thank you, Blinka.
All right, open source hardware. As I mentioned before, Kyle was on our show. Kyle is the CEO of iFixit. We posted up about this. Dear New York, it's time to speak out for your right to repair. What is this? Well, New York is very close to getting something that makes companies more like Adafruit. This bill that's going through, that's going to get voted on tomorrow, it is, and I'll just summarize, an act to amend general business law in relation to the sale of digital electronic equipment and providing diagnostic and repair information. Summary, it's a little bit of a translation. This bill requires original equipment manufacturers, OEMs, to make digital diagnostic and repair information for digital electronic parts and equipment available to independent repair providers and consumers if such parts and repair information are also available to OEM authorized
And
repair
this is
providers.
such a low bar. They're not saying you have to release. They're saying if you have authorized groups that have access to this information, it should be legal for people who are not the officials to have. They're still not authorized, but they can at least look at the manual, which is how it used to be, right? Like I repaired so many things by Googling for the manual, getting for the manual, the repair manual for like the ice maker, or for the board loader, or for an AC system, whatever, and using that to help repair it as an independent person.
Yeah.
Or if you have it, take it to a repair shop, you would take it with a manual and they would do it for you. Like I know how to solder and debug stuff, but maybe you would go to a repair shop. That's the bar. It's like if there was an official place that had it, independent places should have it. That means
Also,
more people can repair
like,
stuff.
If on other causes that we all care about, or at least a lot of us do, if you want to make things not show up in the trash heaps, you have to be able to repair them. To be able to repair them, you have to have some information. So this is a good step. I think people are going to make this happen, and hopefully this will be something that...
Check out their website.
gets-
They make it real easy
Yeah.
to notify your representative.
Yeah, you can go to newyork.repair.org or go to repair.org and put in your state, and you can see how to get a hold of your representative. All right, well, we are an open source hardware company, as you may know, because we just talked about that a lot. But the proof is in the pudding. We have 2,400.
What is it? What's actually in the pudding?
I don't know. I hope that's not a phrase that you're not supposed to use anymore. So it's 2,490
Oh, we're
guides.
close to 2,500 guides.
We are. So
That's
I'm going to
sweet.
do these one little chunk at a time because we got a lot this week. What's the first
Okay, we have
round
a
of
couple
guides?
updated guides too. So we had so the bottom. Okay, so the sharp memory display that got updated. We just made a couple page updates. The Discord and Slack connected smart plant from Dylan is just what you think. It's a Wi-Fi connected CircuitPython board that will send you a Discord or Slack message when your plant needs watering. It's a great demo of using these APIs with IoT products. JP, I think this is also an updated guide. The touch deck, the square pixel art display, the Feather RP2040. CircuitPython, the Arduino Nano RP40 is a new guide from Liz, and the updated guides for the Rotary Trinky and the BME 280. So those are not new. Those are just
Okay.
updated.
Yeah.
But if you want to show them anyways, I mean, it's
What, the little...
little video.
This?
Yeah, I mean, it's fun.
Okay.
Yep.
All right, what else?
And
go to
the
the next step?
yeah, so these are just updated guides.
Okay.
We already talked about those. And then the top, okay, so these are the 4 new guides for this week.
Yeah.
We have from Goolsby, we've got a improved AMG 8833 Pi Gamer thermal camera. So what's cool about this guide is it builds upon the previous thermal camera project and does a lot more graphic stuff, improves the display, and uses ULab, which is the NumPy-like library that we have with accelerated number manipulations, and like you can do mathematical and matrix calculations much faster in CircuitPython. So it does bicubic interpolation to turn your 8x8 camera into something that looks more like 24x24 or 16x16 using bicubic interpolation. That's something in ULab, and normally that would be really slow to do in CircuitPython, but by using ULab you can kind of like push through a lot of data and have it all done for you, optimized, the same way NumPy does it optimized in CircuitPython. We've also got the Python Edge speech recognition with voice to JSON. You sent me a link to this.
Here, yeah. Here's
So yeah,
the-
let's show the
here we have
video.
Tell me the time.
The time is 2:36 p.m.
Show a cat picture. Show an Adafruit picture. Set the left light to red. Set the middle light to yellow. Set the right light to green. Show a cat picture.
All right, what else?
On the Edge, which is cool. JP did a deco theme 2-key feather macro pad using the macro, the 2-key feather wing, like the Neo key feather wing, plug into any feather. And then he showed playing some speed games. And then Liz Clark and Noam Pedro did the Funhouse IoT fume extractor. So this is a kind of a cool project showing how to use IoT and CircuitPython in the Funhouse to read air quality sensor data and then control a fan with it. So it's like, even this is kind of a little bit of an overkill project for fume extraction. It's a good demonstration of how to do this kind of IoT project on your desktop.
All right, those are the guides. Next up, Adafruit Factory footage. Take it away, Adafruit Factory. All right, and then we have some factory footage, but outside the window, we have a couple tracks this week. This is Disney being built across the street. It looks like they're making it taller so they can make the building taller. And we also have some other footage, same thing. So they're making the crane. See, the crane is making a crane.
Oh, God.
Pretty soon, all of the world will just be cranes.
That's a nice little transition.
All right, 3D printing, Noam Pedro, printing up Storm. This week, we're going to do 2 videos back to back. We have a little key press thing, and then we have a fun speed up. Take it away, Noam Pedro. don't forget every single Wednesday 3D Hangouts with Noah and Pedro. Next up. This week's Eye on NPI is Milmax.
Yes.
First off, this logo is great.
It is a really cool logo.
What does Milmax do?
Okay, I think this is our first Milmax product. So Milmax, they're known for their connectors, and so when this popped up, I was like, I know exactly what this is and what it's good for. This is the 3305 sockets for mechanical keyboards. That's what they're selling them as, and they look like this. And you're like, okay, so it's like a little round yellow thing. How to use that? Well, this is a kind of cool thing. So what you do is, it's a really nice rendered image. You can see on the left, there's a mechanical key that's about to plug into a PCB. And normally these mechanical keys are soldered into the circuit boards, and that's how they are held in place with the two contacts. Well, this ferrule, as you see the three things on the bottom, what they do is they get slipped into the what would normally be the through hole, the plated through hole in the circuit board that you would plug the mechanical key switch into. Instead, when these get soldered in, the switch becomes removable because there's little grippies on the inside. You see kind of in the middle there on the second switch, there's little grippies inside that will grab onto the rectangular tabs of the switch and hold them mechanically in place but still allow you to remove them. These are designed to be used with Cherry MX and compatible switches, which you can also get at DigiKey. What's really nice about Cherry MX compatible switches is they all have this kind of thing going on the bottom. You see there's like a big circular mechanical, placement knob, and then there's two rectangular pins, and those pins are what are the switch. They're normally opened. When the switch is pressed, they're closed. They're closed together in contact. So this is a circuit board layout for Cherry MX switches, and you can see there's LEDs and stuff. But basically, you've got the two pins, you've got the hole, and if you have those, you can use these MX switches. And these have been used for decades. These are very old switches. They've been used for a very, very long time. And so traditionally, when you get a keyboard or a macro pad or something that uses these Cherry MX switches, a control surface, they're soldered in. So this is what it looks like on the bottom. This is like a Neo key Trinky. This is one of the few boards we have where you would solder the key in directly, and you see that center hole, again, where the switch goes through, and the two pads where the mechanical switch is soldered into. So this has worked great. People have been soldering in these switches into mechanical key slots for a very long time. I've got keyboards with Cherry MXs that, again, historically decades of use. However, there's now dozens and dozens of different types of Cherry MX compatible switches available, and it could be that you have a circuit board that's designed for Cherry MX, but you want to use Gaterons or Kales or Milks or Jades or whatever you want. And it could be also that you want to be able to change out what switches you use, because, for example, on my keyboard I have linear red keys, but some people really want tactile browns or they want clicky blues. Well, what would you do? Well, if you were using a chip, you would use a socket like this, right? This is a dip socket, and we've talked about these before. You solder these in, and they mechanically go into the same holes that a dip switch or dip chip go into. But what's nice is that then you can, fairly easily remove the dip chip, and you can easily replace it if it gets damaged or burnt out, or if you want to try a different chip or whatnot. So what do you do for Cherry MXs? Well, in the last few years, there's been this invention of the Cherry MX socket. And this is a Kale socket. Gateron also makes sockets that are compatible. And these get soldered onto the bottom of a PCB. And you can't use the same layout, right? It's a different layout for these because you have these big SMT pads. As you can see, the 4 sockets in the middle there. But if you have a modified layout for these sockets, then you can see the 2 holes. You can plug in the Cherry MX into the holes, and they're mechanically held in place. So again, you need to have a new layout. So this is like a layout showing there's no through holes, plated through holes. Instead, there's 2 SMT pads where the socket pick and places on, and then creates the 2 holes that the switch goes into. So if you're making a new design and you have the space, using these pick and placeable Kale sockets is great for mechanical keyboards, but like I said, there are some cases where you have a board that already has, it's already been designed. You can't change the layout, or you're reworking an existing board. You want to change the switches out. In that case, that's where you would use these Mil-Max sockets, because they're actually so thin that they can be put into the PCB that has already been designed with the standard Cherry MX through-hole, plated through-hole holes, pads. And this gets soldered in.
That's cool.
It's so skinny that it can go in and yet still have enough clearance to let you plug in the socket. Sorry, the switch into the socket. There's a lot of S's here. So they come in different lengths, and they're open bottom. So, the switch, even if you have switches with different length pins, they're not like closed bottom where it could bottom out. It goes straight through, and you can see inside there's two little grippies. There are a couple different grippies that will grip onto the rectangular tab of the switch. So there's been previous versions of this, I think 0305s and 7305s, but these ones are a little bit better quality. They're getting better at, the top of the ferrule is thinner. These are gold plated. They're beryllium copper. They're very good quality sockets, so they're quite nice. They'll last a very long time. They're good for any high-end or just hobbyist desires for replaceable switch sockets. Another thing that I thought was kind of nice is, although the ones I got came loose, you can get these pick and placeable. So you could pick and place them into your design, and then with a little bit of solder paste on the pads, you could have it be soldered in place automatically by your pick and place line, or you can do it by hand. Either way. So I thought you want to show the part number, and then we'll show you overhead?
Yeah, so it's on DigiKey, because INMPI is brought to you by DigiKey, Adafruit. And
yes, and they have them in stock.
There. There's a giant product ID. You want to use a short URL, or it's in the chat.
Or just search for Mil-Max 3305.
Or search for Mil-Max.
Which is
easy to find.
Get you what you want.
And so we have two things. We can do the overhead, and then you also send me a video.
Yes, I have a great little demo that I can show. Okay, great. So this is the Neo Key Trinky. So again, this is one of our only designs that you would solder in the switch. And the reason you had to solder in the switch is because it's just so packed. There literally wasn't enough space to put in a socket, because the sockets are quite large. This is what the sockets look like. So you see, they're quite big. They wouldn't fit on the bottom of this PCB with all the other circuitry. And so, just focus lock. So for this, you would solder it in. Now, normally you would solder it in and it would be permanently connected, but with this one, I have soldered in the Mil-Max 3305, and so you can barely see it, but there's this very slight bump. That's the top of the ferrule, and then it goes through to the bottom, and you can see here how it sticks out. I just did put a little bit of solder in, and then it works very well. You plug it in, it's mechanically secure, but then when you give it a yank, it can come out, and you can switch out your Cherry MX switch. Now, you're probably like, look, Lady Ada, I'm not obsessed with keyboards the way you are right now, so what is this good for if I'm not into that? This is good for anything, right? So even though I'm using this for Cherry MX switches, you can make custom sockets for Nixie tubes or specialized sensors that are not on a 0.1-inch grid, or really anything that has through-hole parts, but you don't want to solder it in because it's expensive, or because it gets damaged, or because you want to try different versions. What's nice about this is it doesn't stick up. There's a very, very, very slight bump, but you pretty much get to have it sit flat. And again, as long as the hole is, I think, 0.06 or 60 mil, it goes in the hole, but you can also solder into it. So you can have like a mix and match design, or you could have it be socketed, or you can solder it directly, but without that height change of the dip socket.
Yeah.
So I thought this is a very interesting and useful part, not just for keyboards, but for other mechanical uses where you want to swap out expensive sensors or components.
And Mil-Max made a video. We're going to play it.
As a product design engineer, you know that connectors play a critical role in the electrical system of any product you design. It is not the place to take shortcuts, and a good connector can help avoid costly repairs and recalls down the road. When you design your next product, consider the Mil-Max receptacle first. The quality and reliability of our two-piece construction delivers maximum performance and durability in every application, including challenging or rugged environments. Our receptacles are precision machined for ultimate reliability of critical components across a wide variety of industries, including aerospace, military, medical, just about anywhere product failure is not an option. The MillMax two-piece receptacle design allows for the widest mating pin acceptance range, the largest variety of shapes, sizes, and materials, and multiple contact points to ensure a dependable connection every time. Pin receptacles are typically the backbone of any interconnect system, so why settle for anything less than the maximum in performance, reliability, and flexibility? The predictable quality of a MillMax interconnect can play a fundamental role in determining your product's performance. With almost 45 years of experience working with suppliers all over the world, consider specifying MillMax receptacles into your design sooner rather than later, and ensure the optimal solution for the unique requirements of your application.
And that is this week's Eye on MPI.
Thank you, Millax.
Okay, so before we get into new products, codes, keycaps, load up the cart. Get ready. All right, lady, ready to do
Truck
this
it
thing?
out. Yep.
New product time.
New.
All right, first up,
Okay.
it's space-time. No, it's it's a grid of space-time that
Oh, that's
bends
right.
with gravity.
Yes, you can bend this grid.
Get it space-time? Because we also have a space-related thing.
yeah,
Yeah, it's kind of cool.
yeah,
Anyways, so it's a grid of paper.
Okay, so this is actually a sample that I got for an Ada box like a couple of years ago, and I got a pack of 10 of these because I was thinking, oh, maybe put it into the Ada box. We ended up giving away a gridded line notebook, but I actually really liked these gridded sticky notes, and they're pretty expensive. They're like $1 for 80 sheets, and they're exactly what you think they are. They are gridded sticky notes. So
right,
here you
switch
go.
on.
Hold on, let me zoom out a little bit. So you get 80 sheets of sticky notes, each one. Each one has a grid, which I think is really handy if you're like drawing circuitry and you're like, well, I really want to make very beautiful op-amp diagrams and stuff, and like you want like your transistors to look great, whatever. You can also do it for like kanji or hanji, or if you're doing pixel art or whatever. And of course, it's sticky, so you put it on and you stick it off. It doesn't leave any residue. They're fun. They're
You're
wonderful.
an engineer. You need these.
I really like. This is
Yeah.
actually one of those things that I was just like, I kind of need to have these in store because I couldn't find them anywhere else.
Next up.
All right, next up we have these little silicone inserts. You know, it's kind of like dusty because there's construction happening next door. I don't know if you saw the Disney construction. So these are little like silicone nubules that are designed to fit RJ45 Ethernet, or you know, some phone systems use RJ45. They plug in, but they're easy to remove. They're nice silicone, squishy, very handy. Come in a pack of 10. So even if a whole hub of 6 or 8 ports, you've got plenty.
Next up.
Next up, we have an assembled version of the Music Maker Featherwing. This features the VS1053. It's OGG Vorbis, AC, MP3, of course, like VMA, MIDI player. We have these Featherwings, you know, for sale. They're unassembled, but we had some left over. We found these were actually in an Ada box a while ago, and we're like, oh, we have a couple dozen of these. Let's put them in the shop for people who don't want to assemble them. They want to just plug and play them onto your Feather. Works just like the other Featherwing, and they have an amplifier built into, I think, a stereo 2-watt amp left and right, so you can use 4 or 8 ohm speakers and get your music playing super fast.
Next up.
Next up, we have a revision for the 1.54-inch e-ink display. I believe this is now using the SSD 1681 chipset, or it's 1680, and it used to be something else. The e-ink chipsets have been changing around. We have drivers for all the different chipsets. These are the same look and size as before, but if you have programmed these with firmware, you'll need to update the firmware on your microcontroller or driver for SSD 1681. It's a very good chipset. Other than that, it's just that the previous version of the chip driver was discontinued, and this is the new version, so that's an updated product.
Keycaps, 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 keycaps.
Okay, so now we're getting into
Let me just click through each set
the
right here.
majority. Well, I mean, these are some clear ones and some black ones, but basically we have a large number of DSA or XDA. I don't know if you saw Colin's video we had earlier.
I did.
Explaining about profiles of keycaps. So these are symmetric low profile DSA, sometimes called XDA chip keycap sets. And let's go to the overhead and I'll show.
That's the best way to show them.
Okay, so yeah, I really quickly grabbed
Like
mine.
candy.
Yeah, they're very colorful. Okay, so this is not all of them because we also actually have the black and the smoke and the gray and the white and then the translucent, the translucent red and blue. But these are many of the colors. So we've got clear, red, orange, dark yellow, neon green, mint green, light blue, blue, dark purple, light purple, pink, lavender and pink. So these are the colorful, and these are opaque. This one, as you can tell, is of course translucent, which means if you have a backlit LED, you'll see through it. We also have other translucent keys, which you can see quite nicely here, how they're translucent. This is smoke translucent, blue translucent, red translucent, gray, not translucent, opaque, white opaque, and black opaque. So many colors. They come in a pack of 10, so you can pick and choose. Of course, they don't have any markings on top of them, and they're completely symmetric. So like they fit any Cherry MX key, and they're symmetric no matter which way you put them. They don't have a tilt to them, which makes them, I think, personally, really great for macro pads because you want to have them all be kind of flat to have a good look for the ortholinear design you got here going on here. So those are the different color pack of keycaps. We have so many that we're just going to show them all at once here. But they're all really wonderful colors.
All right, next up, coming soon. This will be in the store shortly. This is the CircuitPython Space Explorer sticker.
Holographic.
It's hologram-like. It's holographic-like.
It's holographic.
Yeah. So it's a beautiful sticker, and we're doing a lot of space-themed stuff. So if you want to get this, we're going to make a round, and that's going to be it. These are CircuitPython Space Explorer, and CircuitPython is actually in space. It's used on those little small sets.
Mini sets, yes.
All right. And now tonight, the star of the show, besides you, Lady 8, our community, our customers, and our Adafruit team is...
That's right. It's time for the RP2040 QT Trinky.
Bong, 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 bong.
Thank you, Bongo Cat. So this is a new Trinky, and this Trinky has a lot of different purposes. So first off, it plugs into your USB-A port, of course. It's extra thick, so it fits snugly inside. And it has inside of it an RP2040. Look at the beautiful photography with the Raspberry Pi logo. It's got 8 megabytes of flash on the left there. It's got a reset and boot button, so you can reset it. And the boot button is also a user button, so you have like one input button if you need. There's a little NeoPixel for status, or if you want to blink an RGB LED. And then on the right, the buttons are on the side. And the reason for that is because the shape of it is 1 inch. The body is 1 inch by 0.7 inches, which is the same as like the majority of our STEMMA QT sensors, which means that you can, if you have some M2.5 machine screws, nylon screws recommended, so you don't short anything out, you can attach it on top. You can still get to the buttons even though something's attached on top. So you can make kind of a customized USB to I2C connector. And so here, for example, what's interesting about this is that you could have CircuitPython running on this board, which I think in this case is what's going on here. You program it over you program it over USB with CircuitPython running on the RP2040, and then say connected to this I2C OLED. Or what you can do is you can drag and drop this special firmware called U2IF, which I know sounds a lot like UF2 or U2F, but it's not. It's this intermediary format that does USB to I2C, and then you could use CPython on your computer to send data to the RP2040, sort of like a little bridge USB to I2C device, so you can use it to program any of your STEMMA QT enabled devices, OLEDs or displays or sensors or fan controllers or what have you. And the RP2040 is powerful enough, has enough RAM, and there's enough storage on board that you can basically have every single Raspberry Pi driver on there, and it's definitely fast enough to drive and have enough memory to drive any of our sensors and devices. So, we went with the RP2040 because it's inexpensive but powerful, and it's a great USB Trinky friend for connected to any I2C device. So I think I could show it on the overhead, but honestly, the images we have.
I was going to say, I think this is it.
The images are quite large and good. So, yeah.
All right.
RP2040 QT Trinky. Lots of fun. I think we even put some in the shop already.
That's all of our new products for this week. We did it.
Yay! Oh, that was nice. Fancy.
All right, cool. So
Let's go
don't
back to that. 'cause
forget.
That was cool looking. Let me see that.
This is what we make. This is
Oh
what
my
we
God,
do.
it's like a summoning circle.
This is what we do.
We summon the
It's what we do.
keebs.
If someone says, "What do you do?" This is what we do. Okay.
Okay.
So don't forget the code keycaps. 10% off until I turn it off. Let's do some top secret, Lady Ada, and then folks have some questions already lined up. Put them in Discord.
Cool. Put your questions in now, and I'll get to them after top
Yeah.
secret.
So top secret. Let's kick it off.
Let's open up the
This
vault.
week, I'm just gonna play these videos, and I'll see you on the other side.
Cool.
Okay, Lady Ada, what is this?
Hey, we're back at the Adafruit factory making prototypes. My stencils didn't come in yet, so I'm hand pasting these prototypes for my RP2040 keyboard with OLED and rotary encoder. And the way I do this is I actually have solder paste in this little dispenser, and I've got a nice fine tip on it. And then I very carefully squeeze paste onto the pads. I try to get it as clean as possible. I'm gonna have to clean this up later with my soldering iron, but you just want to get it good enough so that the components sit in the right place. And then I'm going to use this collection of all my raw components, hand place them on, and then the best part is it goes through the oven, which saves me the most time. So this is going to be very fast once I pick and place all the components on by hand.
All right, Lady Ada, what is this?
Okay, so I put together the prototypes for my macro pad with all those LEDs and buttons and the OLED socket and everything. And then I got home and it's time to actually put it to the test. So this is some Arduino code running on it that you can see it reacts to when key presses are pressed. I can press them all. Yeah, there you go. There's also the rotary encoder, which you can see as I turn it. It goes the right direction, and when I press it, it also knows it was pressed. And then finally, I'm doing a little I2C scan with the STEMMA QT sensor, so you can see here. When I have it plugged in, it says there's something detected. When I remove it, it's like there's nothing detected. So this is my little hardware bring up test. But so far, so good. I have a couple tweaks to do, like, you know, it's a little embarrassing, but I actually had to add a couple of 10 microfarad capacitors. I needed more capacitance, but I think it's almost done.
All right, Lady Ada, what is this?
Okay, so I'm still working on the bring up of my macro pad boards, and I just finished doing the Arduino core. So this is Arduino code. Here you can see it's rotating and like keys are being pressed and all that. And then on the other one, I got two prototypes. I've got this with CircuitPython one. You can see because there's a blink a friend. So this one, I just had to do a little bit of like a patch to the core to fix like a typo bug for the SH1106 OLED driver because like the columns and rows were mixed. But I did that, and then my driver is like working great now. And then this code is, you know, kind of similar. When you press the keys, they light up. And you get the rotary encoder and the rotary button press working as well. So it's good. It means I've got the hardware working on Arduino and CircuitPython, which means it's time to write some macropad code.
All right, Lady Ada, what is this?
Hey, I'm trying out a sample I got of these lamp keys. These are interesting keys. They actually showed up on JP's video. He's been like loving these lamp keys. You see, it's an opaque black plastic key within this clear window that like you have neopix or LED glow through. They have this kind of cool like modern cyberpunk 80s look to them, which I really dig. So after I asked JP what they were called, I found a supplier. They're not super cheap, but they have a great look to them. And you can see the clear window here and then the neopixel shining through. And then this is the clear cast RP2040 key that I made with my resin kit over last weekend. I'll probably be doing more resin stuff this weekend, but these keys look pretty cool. I mean, like they're just, I don't know, they're like super cyberpunk. So I think these are good. We'll put them in the store.
All right, Lady Ada, what is this?
Hey, we are looking at some mechanical keys today, and so folks are pretty familiar with these. These are like the Cherry MX style switches. This is actually Kale switches, and there's this one with a keycap. But you might be like, man, these are so chunky. I mean, they're great, but they're a little tall. I mean, like, you know, look at this board, and it's kind of sticking up. What if you want something slimmer? Well, there's the Chalk series, and the Chocolate series from Kale are super slim. So I got some samples, and this is the one with the keycap. Like, compare this to this. It's like so much slimmer. And then there's one, here's a really nice clear keycap. Only thing is that the keycaps are totally incompatible, and the bottoms also, you know, I had to get special sockets the socket bottoms, the pin bottoms are also totally incompatible, as you can see here. So it's kind of a whole different system, but they're super small and skinny. This one's a clicky one too. Sounds good.
All right, Lady Ada, what is this?
Oh, I got some cool samples in today. So this is a custom etched keycap. It's a translucent plastic with like a black plastic that is then etched through, so you can see it's got the Adafruit logo in cool glow-through design. So looking great on this macro pad, whatever the color of the NeoPixel underneath is what it goes through. I also got the OLED working with the offset and everything in CircuitPython, so that's good news. And then when I press this button, bam, opens up Adafruit. I just programmed the macro pad, really easy to make it do anything on your computer, so I just made it open up a browser window. It's very cool. Custom keycaps coming soon.
Dun 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 dun
Dun, 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 dun. What am I singing?
Yeah. All right. So we
I
have one
it
right
too.
here.
Yeah, I have one. I can show. I don't have this plugged in, and of course
Yeah.
it's not running, but it's a translucent etched keycap,
It's one of the few things we'll put our logo on.
which is really cool. So it's actually a translucent plastic, and you can see there's a thin black layer, which means we can get custom etched keycaps. We already have some goth keycaps on the way.
We got some stuff going on. And then last up, got to read the room here. So we're doing an e-ink Trinky.
Yeah.
So do you want Squid Friend?
Squid friend?
Or do you want Panda Friend?
Pan friend? Squid friend or panda
Squid friend?
Squid?
Or Panda Friend?
Panda.
Squid Friend or Panda Friend?
I'm not going to tell you which to pick, but you should pick panda.
Squid Friend or Panda Friend? All right. And with that is Top Secret for the week. Okay, we're going to do the questions. I have them lined up. We're going to go through them fast. So speed round, Lady Ada.
Yeah, let's do it.
Okay, questions,
Okay.
questions. We're going to put them.
Squid. People like the squid. People just like squid because they're like,
We'll
they watch
say it, we'll
Watchmen.
say it, we'll
and
say it,
they're
we'll
just
say it,
like,
we'll
we
say
want
it.
killer squids.
Okay, you ready?
Yep.
Okay, questions. I'm going to answer this one.
Yep.
With all the chip shortages, are you going to be shipping a box in the next one, July, August?
Yes, July.
Okay, I'm a digital artist. Can you sell the MacroPad pre-soldered?
It will be soldered and not like it's going to be fully soldered. All you have to do is plug in the keys. So no soldering will be required for the MacroPad as is because we've got these Kale sockets.
Okay.
That make it easy, but you'll customize it however you want. Like we'll have a key kit that you can use, but if you want to use like your milk jade, milkshake, cherry blossom keys, you can go ahead and do that.
Okay.
That's a real key type, I think.
Can the selective solder machine be used to bridge PCB jumpers so a knife is not needed to open the jumper?
It's not a good idea, although you can use solder paste to do it. I actually prefer having the knife blade openable ones because you can use a little screwdriver or something else sharp. I don't recommend using the tip of a soldering iron, but you can do that too.
Okay, next up, let's see. Well, so that socket, was it designed for future compatibility? It's amazing that it's transparent.
I'm not sure which socket, but
I think it was for INMPI, the thing. It was.
Yes, it's designed for Cherry MX compatible switches, and there's again a massive family of hundreds of different switches. So this means you can use older designed PCBs and you can upgrade them to be socketed without needing to change the PCB layout.
Okay. Next up, could the Milmax 330s be added to a Neo key as an aftermarket part?
I'm going to look into it. I did not think of it because, of course, at the time I didn't know about these. These are an NPI. It just came out.
How many insertion removals are on those Milmax rated at?
I don't remember. I don't remember seeing it, but I'm going to guess like a dozen.
Okay.
You're not supposed to constantly be removing them and replacing them. It could be 30 or so, but eventually the springs will start to get either dirty or they won't be as springy. So I'd keep it to a couple dozen.
Can they be used with rotary encoders like the Neo Key Trinky?
You check the specifications of the width. I only tried them on this because it's exactly what they're designed for. But anything that has that size hole and those size pins will work.
Okay.
So many things.
Can use them with resistors.
Again, if it's the hole in the width of the wire, yeah, you can use anything. It's not only for Cherry MX switches. It's just that's what they're selling them as.
Okay. Would we stock them?
I'll look into it. Yeah.
Okay.
But for now, you can buy them DigiKey, and they're cheap at DigiKey.
Why do some boards use dot stars and others use neopixels?
It depends on historically if you wanted a very tiny LED like on a trinket or a gemma, only dot stars came in that size, but then neopixels started coming in that size, so now we use neopixels in that size. There's also some chips that they're friendlier to use dot stars with, like the Funhouse. It's an ESP32, and the NeoPixel code for the ESP32 still has a couple like bugs that we're figuring out. So to be safe, I use dot stars for that because again, they're the same size, and I had the extra pins. So that's why some I use some, and some with Raspberry Pi for the Braincraft hat. Again, Raspberry Pi, you can use NeoPixels, but you're better off using dot stars. You're going to get more reliability.
All right. How much clearance do you need between cap touch pads on a PCB?
There is actually a number for this, and I believe it's 10 millimeters.
Okay. Whoops.
Yeah.
Mike's moving around here. Next up, I know CircuitPython doesn't handle IRQs. Those are handled in C code. Can it be done in inline assembler? I'm looking at some instructions of lower lib that versus C++
I don't
version.
believe we've turned on the inline assembler because even if we did, then you'd have like ESP32 versus ARM core, and there's different ARM cores, so we don't have that. You could post up an issue asking for advice on how to solve your problem because we do have some things like asynchronous, or there could be some existing helper code that could get you what you want. Doing concurrency and interrupts in Python doesn't work even if we had it turned on, it isn't the way it works in C, which is why you don't have it turned on. It doesn't, you have a state machine, a virtual machine, so interrupt the entire virtual machine, not inside the virtual machine, right? It's not as easy to handle. So there could be other ways to solve your problem. So post in the thread we have of like asking people how you want to use interrupts or threads, and we might have a solution for you. There might be something that exists that we can repurpose, or you can repurpose to do what you want.
All right. What were those module component boxes that were in that MacroPad video?
We have them in the shop. They are called like modular component boxes.
Do the ferrules need to be oriented prior to soldering with the plug-in?
No, they're fully
contacts?
symmetric. They're round. They have multiple little grabby arms.
All right.
So they're not oriented.
Let's see. I think here we go. Questions for the show. How difficult would it be to make a Trinky that has Apple Lightning connector? I know there's a MiFi program. Just curious if it's feasible. I'd rather give the extra money to Adafruit than Apple for a USB connection.
No way, really, to do it. But they're moving to USB-C anyways, right? So.
Okay. Yesterday, someone was Panda. Now today, they're Squid. Panda friend, Squid.
Oh no, the squids are winning.
Yeah. Okay. Any ideas where to learn about designing and manufacturing MEMS?
Check out Analog Devices. I think they have a bunch of resources on how they design their MEMS sensors.
Okay. How's the Adafruit logo put on the key? Are they sold bland, and can we etch ourselves, or are they pre-etched?
They're pre-etched, and no, I cannot get keys that are etchable. Yeah. I believe I'm looking into it, and it's not easy.
Squid,
and also, you can't use a laser cutter. You have to have a very specific type of tool to do it.
Okay, international peeps on my next visit to New York City. Do you have factory tours? Nope, but we do
not.
lots of videos. So do check out all of our factory tour videos because we would not be able to do tours for everyone. We wouldn't be able to make electronics. We'd just be doing tours. Someone's dog name is Panda. That's kind of nice.
Okay.
And then did we decide using the Panda or other characters for that one thing? No, we're trying to figure out.
We're asking you.
Is the e-ink Trinky going to be Squid or Panda? This is not a menu. These aren't, I mean, we can eat one of them maybe.
Oh no, don't.
And I think that might be it.
Stop eating our mascots, folks.
I think that is...
We can have a cicada mascot or something.
Yeah.
Those are cool.
And those are the questions for the night.
All right, thanks everybody.
So, just a little bit of reminder.
There's a code.
Keycaps is the code.
Including the codes, the keycaps we have in stock, by the way.
Yep. Hope everyone enjoyed the show. I want to say special thanks to Jessie May, working behind the scenes.
Thank you, Jessie May.
Doing all sorts of stuff in our Adafruit Slack, helping out folks and more. And special thanks to our community out there, our customers, all the Adafruit team members. We'll see everybody next week. Thank you so much for everything. And don't forget, there's something that all of us can do as makers, as technologists every day to make the world a little bit better. I hope we showed you some things to give you some ideas about how to do that and more. We'll see everybody next week. Here's your moment of Zener.
Thanks, everybody. Have a great week.